And lastly, question 9 and 10 are scenarios, more of our scenarios. The total cost of cans of tomato soup is 95 cents per can. We want to write a linear function. So they defined it, everything for us. So to get that total cost of cans, it's 95 cents a can. So your cost of tomato soup is going to be 95 cents times each can. Now when it says evaluate T of 5, interpreting means bought 5 cans at, and then this is where we're going to go and type in 95 cents times 5. So 0.95 times 5 gives me 475. So we bought 5 cans of soup at $4.75. How many cans of tomato soup will $7.85 purchase? So this is where we're going to set that equal to the outside and divide by 0.95. And 785 divide it by 0.95. And we get not a nice number, we get a decimal. So we need to think about where we can round that. And in this case, we're going to have to round it down to 8 cans, because 8 times 0.95, let's see, 8 times 0.95, that's 760, which we can afford that. But if you were to say 9 cans, 9 times 0.95 is 855, and we would not be able to say afford that. So 8 cans is what you can afford. All right, last one then is number 10. The marching band sells cake pops during the home football game. Each cake pop costs $1.50, and they also give out 15 cake pops at each game. All right, P is going to represent the number of cake pops sold, and E of P will represent the amount of earnings. So the linear function is, okay, well, we're making $1.50 off of each cake pop. So that is my rate. And that would be fine, but we are also losing money. We're losing money because we're giving out 15 cake pops. And 15 times that $1.50, 15 times $1.50, we are losing $22.50 each time, $22.50. Now, it can be written like this, or you could see it in factored form, written as that 1.5 times P minus losing those 15 cake pops. I'd be fine with either one. Evaluate. So 125, that means 125 cake pops sold and made. And this is where we're going to evaluate it. We're going to plug in 125 for P, take out the ones that we're losing. So 1.5 times 125 minus 22.50. And we are walking away with $165. Okay. How many cake pops needed to purchase in order to break even? Again, break even is where you go from negative to 0. That's the break even point. So I need to recoup the cost of those 15 cake pops. So I would need to sell 15 of those to break even on the ones I gave away. All right. How many cake pops were purchased when the club raised $350? So that's what we're going to set that equal to. And then use our skills we've been doing to solve for the variable P. So I'm going to add over that 22.5. 350 plus 22.5, and then we're going to get ready to divide it. So 372.5, and we're going to divide it by 1.5. 372.5 divided by 1.5. To raise $350, let's see, we are going to have to sell 249 cake pops. If you where are we at? Okay, the decimal's not nice, and if you said 248 is the answer, well, you're going to be a little bit short. 150 times 248 minus that 22.5, we would be at $349.50. So we'd be short 50 cents there. That's where I do need to round that back up. And if the club decided at the last minute to give away additional 10 cake pops, how would that change our linear function from the very beginning? So instead of giving away 15 cake pops, we're giving away now 25. So we're going to take our original. So this was our original, which is 1.5 cake pop made minus 2250. If you're in factored form, it would look like this. But now, the new one, we are going to have to account for 15 more cake pops. So, sorry, 10 more cake pops. So we're going to have to do 25 times $1.50 we're losing, because 15 the original, 10 more. So 25 times $1.50. That gives me 37.5. So we're now losing actually $37.50. Or if you're doing the factored form, which either one would be fine, that's where we're doing P minus 25, because 15 original plus 10 more. How many cake pops would now need to be purchased to break even? Well, to break even, we need to recoup 25 cake pops sold. Okay. Again, either equation would be good. I'll take that in slope-intercept form or standard form, or sorry, general form, or factored form right there. Either